Section number 51 is entitled Adding and Subtracting Square Roots. So like always, let me motivate what I'm about to do. I'm sure almost all of you will know that 3x plus 4x is 7x. In fact, I generally ask this question to my algebra students. It's two parts. I'll ask them what 98x plus 2x is. And mostly everyone would say that's 100x. And then I'll ask them to calculate this. I ask them to calculate 98 times 8 plus 2 times 8 without multiplying that out and without multiplying that out. And surprisingly, next to no one gets this problem right. But the answer is right above. The answer is right above. I'm just telling you what x is. If this equal sign is valid for x's, and it is, 98x plus 2x is identically 100x. They are equal. Well, if they're equal, then it must be true for any value x. Like 98 times 3 plus 2 times 3, it must be 100 times 3. And of course, I do have a typo, excuse me, x is 8. 98 times 8 plus 2 times 8. Okay, so let me ask you again. How would you calculate 98 times 8 plus 2 times 8 without actually doing 98 times 8, figuring that out, and then doing 2 times 8 is 16 and adding them up? Well, the answer is if you have 98 8s and you add on 2 more 8s, well then you have 100 8s, which is 800. And again, this was definitely not a problem to run and get a calculator for, especially if you know the equation in the box. 98 times any number plus 2 times any number is equal to 100 times that same number. 98 times any number, 2/3, 99, negative 18. 98 times any number plus 2 times that same number is 100 times that number. Well, I'm just telling you what the number is. I'm just telling you what the number is. The line at the very top says 2 times any number plus 4 times that same number is always 7 times that number. So if I now ask you what is 3 times the square root of 10 plus 4 times the square root of 10, you should say, well, you're telling me what x is. Well, x is, 7 square root of 10s. We are adding square root of 10s. We're adding square root of 10s. Here I have 3 of them, and I'm adding on 4 more. So I'm going to end up with square root of 10s. 7 of them. Of course, if you really, really hated what I did, you could, between here and here, the two terms, they're separated by a plus sign. Let me write it down nice and neatly. The terms are separated by a plus sign. Between this term and this term, as clear as day, they have square root of 10 in common. So I factor it out. And what's left over is what I did not underline, namely 3 plus 4, which is 7. And instead of saying square root of 10 times 7, we say 7 times the square root of 10, which is what I have on the line above. Think of these radical signs as x and y in z. times square root of y? Well, we're subtracting square root of y's. I have 8 of them here, and I'm taking away 3 of them. Y, I have 5 of them. When you think the square root of y is x, you have 8x, and you take away 3 x's, you have 5 x's. If you have 8 square root of 13, then you take away 3 square root of 13, you're left with 5 of them. Now, what if you have the square root of 98, and you want to take away the square root of 72? So we need to break these up. We need to simplify these. We need to write it as something like 8 times the square root of 13. So what we need to know is the numbers that we know the square root of. We know the square root of 2 squared, that is, we know the square root of 4, it's 2. We know the square root of 3 squared, that is, we know the square root of 9, it's 3, etc. 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, and 12 squared is 144. We know the square roots of the numbers that I just circled. Now, to solve such a problem, you need to ask yourself, what's the largest number that we know the square root of? That is, what's the largest number on our list that goes evenly into 98? Well, numbers bigger than 98 won't go into it. 81 doesn't go into 98 evenly, because 81 times 2 is already bigger than 98. 64 won't go in. 64 times 1 is 64, below 98. 64 times 2 is too big. 49 goes into 98 2 times. Now we have this rule. It's a very important rule. If you have the square root of a product, and for now we'll say A and B are both positive. A, B, both positive. The square root of a product is the square root of, in this case, the square root of A times the square root of B. You can take the square roots separately and then multiply their results. So 98 is 49 times 2. So I can take the square roots separately. The reason I picked 49 was, I know the square root of 49. It's 7 times the square root of 2. Now for the record, 98 is 14 times 7. So the square root of 49 is just equal to the square root of 14 times the square root of 7. Now I'm not going to back down from that. The square root of 98 equals the square root of 14 times the square root of 7. But what I will say is, that doesn't help me. I didn't get to simplify it. Because neither 14 or 7 was on my list at the right. I only want to use numbers that are on my list of minus. Now we play the same game for 72. What's the largest number on our list that goes into 72? Evenly. The answer is 36. 36 times 2 is 72. And I know the square root of 6, and I do not know the square root of 2. So now this last line, this line right here, it's familiar. It's like the earlier problem. We are subtracting square root of 2's. If you have 7 square root of 2's, and you take away 6 square root of 2's, you're left with 1 square root of 2, or just square root of 2. 1 times any number is just that number. So that's how you would do that problem. You need to know the list at the right. Oh, that's not true. You need to be able to write that list. I mean, if you think in my mind that I have the list 4, 9, 16, 25, 36, 49, etc., that's not true, but I can very quickly say to myself, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared, 13 squared. Okay, as quickly as I wouldn't have been able to write it any faster if I actually memorized those 10, 12 numbers. But I just know 2 squared and 3 squared and 4 squared like I know my name. In fact, it's kind of quicker. You need to know those squares. 2 squared, you can know 2 times 2, 3 times 3, 4 times 4. You need to know your times table. Okay, so what if you wanted to do to simplify? These are the instructions. Simplify. Instructions are to simplify this. So you just have to keep asking yourself, when it comes to stuff underneath the square root sign, what's the largest number on our list that goes into it? Look to 75. The answer is 25. It goes in 3 times. So it becomes the square root of 25 times the square root of 3. Plus 2 times the square root of 27. 27. The largest number on our list that goes into 27 is 9. It goes in 3 times. Minus 48. The largest number on our list that goes into 48 is 16. It goes in 3 times. The square root of 25 is 5. Square root of 3. Plus, the square root of 9 is 3. Remember, we're multiplying. 2 times 3 is 6 times the square root of 3. Minus, square root of 16 is 4 times the square root of 3. So it looks like I'm adding and subtracting square roots of 3's. How many do I have? Well, I have 5. I'm adding 6. That gives me 11. And I'm taking away 4. 11 minus 4, I'm pretty sure is 7. The answer is 7 square roots of 3. Now, I do want to say something. If you do a problem, and right or wrong, you think the answer is 8. If you write down a different number like 11, you're going to be wrong. 99 out of 100 times you're going to be wrong. If you think the answer to a problem is 13, and you write down 14.1, you're going to be wrong. If you do that on each and every problem, probably for the whole semester, you'll get 1 point. Most of your exams will be 0. Maybe you'll hit on it 1 time. And even that's going to be lucky. If you think the answer is 134, don't put down 139. I call that being suicidal. Now, why am I saying this right here? Well, I'll hear students say, and they're right next to me, I'm working with them, they'll say the square root of 25 is 5. Now, you and I both know that's how you write 5 down. Why on earth would you now write down 5 that way? If you think the answer is 5, please, please put down 5. Don't put down that. This is not 5. You know it's not 5. I'm not clear what goes on in the heads of students who write 5 that way. They just think square roots. Of course, if you ask them to write down what 4 plus 1 equals, they would write down 5, not minus, not square root of 5. But once they see a square root sign, they think everything has square roots. The square root of 25 is equal to the square root of one number and only one number. And that number is 25. The square root of 25 does not equal the square root of 5. What I find amusing is if a student has the square root of 16, in an earlier problem, they'll say the square root of 4 is, unfortunately, the square root of 2. But the square root of 16, they say to themselves is 4, so they write square root of 4. They leave the answer like that. Well, if you're going to be wrong, let's be wrong. The square root of 4 is 2. Hopefully you'd write 2 down and not square root of 2. But if you really think the final answer is square root of 4, well, you're not done. Okay. This is gibberish. If you think the square root of 16 is 4, write down 4. Why on earth would you write down anything but 4? I mean, maybe you're wrong. Maybe the square root of 16 is not 4. But if you think the square root of 16 is 4, which, well, let's say 5. If you think the square root of 16 is 5, well then write down 5. In this case you'll be wrong, but if you write down 93, you have no chance of being right. If you do the best you can and you come up with an answer, and then you write down a different number, you're probably going to be wrong, don't you think so? I mean, why not just go on an exam and say the answer to 1 is 11, the answer to 2 is 98? Just randomly pick numbers. Alright, let's do one more. Suppose you have the square root of 49 minus the square root of 50 plus 3 times the square root of 72. And having put down this problem, it led me to think of something like this. If you have the square root of, say, 50, and you want to take away the square root of 49, this is not the square root of 50 minus 49, which is the square root of 1, which is 1. It doesn't work. For example, the square root of 9 minus the square root of 4. You need a little bit more space to do that. It doesn't work with subtraction or addition. The square root of 9 minus the square root of 4. Well, the square root of 9 is 3 minus, this is 3, this is 2. 3 minus 2 is 1. But this does not equal the square root of 9 minus 4, which is the square root of 5. 1 does not equal the square root of 5. Now, even if we add these, 9 plus 4 is no longer 5, it's 13. The square root of 9 plus 4 is the square root of 13. And if we add them, this is 3 plus 2. 3 plus 2 is 5. I'm sorry, but it doesn't equal the square root of 13. So, you can't, in the problem that I just put, you can't say 49 minus 50 is negative 1, so it's the square root of negative 1. It doesn't work that way. But what does work is using the list to the right. The largest number on our list that goes into 49 is 49. That is, we know the square root of 49 is 7. 50, the largest number on our list that goes into 50 is 25. It goes in 2 times. Plus 3 times, like always, we try to break up the square root. Unless we know the square root. Notice I didn't break up 49. Square root of 49 is just 7. But 72, I don't know the square root of 72. But 36 is the largest number on our list that goes into 72. It goes in 2 times. So I have 7 minus, this is 5, not the square root of 5. It's 5 square root of 2 plus 18 square root of 2. 3 is 3, And square root of 36 is 6, and 3 times 6 is 18. Times the square root of 2 is 18 square root of 2. Well, these are the three terms, and this is just a number, whereas the other two terms are square root of 2's. So we can't combine the 7 with anything, but we combine the square root of 2's. I have 18 of them here, and I'm taking away 5. That means I have 13 left over. You want to do minus negative 5 plus 18? Fine. But that's still plus 13. 13 what? Square root of 2's. Do not add the 7 and the 13. Okay? Just like if you had 2 plus 3 times 4. This is not 20. It's not 2 plus 3 is 5 times 4 is 20. It's this number plus that number. It's not 2 plus 3. And 7, what are you adding to the 7? Not 13, but 13 square root of 2. These numbers are not like, we can't add them. We can just say add them, but you can't actually do the addition. Okay, that finishes the section on adding and subtracting square roots. And you have to know that list, or at least be able to generate the list. And on an exam, I would definitely write down that list in front of me so I can see it. All right, good luck with it.